Okay, so we're back, and in this video, we're going to learn how to actually find the gradient of a curve given of the value of x, and we'll also do a few word problems for good measure. Okay, so here's question number 3 of the same exercise, 12.1. Again, I'm going to do the highlighted parts as always. So here we have the equation of curve, which is y equals to 3x squared minus 4, and you have to find out the gradient, as you can see, dy by dx at the point 1, comma, minus 1. Now, let me tell you something. The y coordinate, if you already have the x coordinate, is completely irrelevant. Okay, why? Because let me show you. If you find dy by dx, now dy by dx is something that's always going to be in terms of x. Okay, so that's 6x in this case. Okay, now what is it dependent on? You can see that it's dependent on just the value of x. So if you have the value of x, that is, if you have the x coordinate of the point at which you wish to find the gradient, that means that's pretty much all you need. You don't need the y coordinate. Okay, so you might wonder that why do we have this y coordinate? Well, in this particular case, it's completely useless. Okay, so now all we got to do is plug in x equals to 1 in dy by dx. So you can see what dy by dx becomes. It becomes 6 into 1, which is equal to 6. So that means the gradient of the tangent at x equals to 1 on the curve y equals to 3x squared minus 4 is going to be equal to 6. Okay. Then comes part C, which before we can differentiate, you know what we have to do? We have to make it differentiation ready. Okay, now when we differentiate this, so 2 is a constant, so that becomes 0. And this becomes 8 into minus 1, which is minus 8. X to the power minus 1, which is minus 2. Let's write this nicely. So this becomes minus 8 upon x squared. This is what dy by dx is equal to. Now, what's the value at which we wish to find dy by dx? That's equal to 2. So we do minus 8 over 2 squared. So 2 squared is equals to 4. Minus 8 over 4 is equals to minus 2. So that means dy by dx is equal to minus 2. Okay, then comes part E. So first thing you want to do is, again, you want to separate it so that you can make a differentiation ready. So x upon x becomes 1. 5 upon x can be written as 5x to the power minus 1. Then when you differentiate it, this becomes 0 plus minus 5 x to the power minus 2. Now I hope you know why this becomes minus 5 and why the power on x becomes minus 2. Okay, if not, then I'd suggest you watch the previous videos. Okay, so now dy by dx equals to minus 5 over x squared, and at what value of x do you wish to find dy by dx? That's 5. So let's see, what do you get? So dy by dx equals to minus 5 over 5 squared, which is 25. So that means dy by dx is equals to minus 1 over 5 or minus 0.2. That's up to you how you want to write it. Okay. Now here's question 4 of the same exercise. It says find the coordinates of the point on the curve y equals to 2x squared minus x minus 1 at which the gradient is 7. Okay. So how is this question different from the questions that we've done so far? In this, the question is not asking you to find the gradient. In fact, it's given you what the gradient is. You can see that the gradient is 7, and what it's doing is it's asking you to find the coordinates of the point. Okay. Now one thing that I want you to focus on is that it's using the word point. Okay, now remember, a point is complete when you have the x coordinate as well as the y coordinate. Okay, so how do we go about this? Well, first things first, you find dy by dx, which is going to be 4x minus 1. Okay, now normally you would have the value of x, which you would plug in and find dy by dx, but in this case you don't have the value of x. Instead, you have the gradient, which is actually dy by dx. Okay, so 7 equals 4x minus 1, which means that 4x is equals to 8 or 8 equals to 4x, however you want to write it. But the idea is that x is equal to 2. Okay. Now, when you have the value of x, what a lot of people would do is that they take this value of x and plug it in dy by dx. Okay. Which is absolutely wrong because you just equated it to 7 to find 2. Now you're plugging it back in dy by dx. That means you're going to get 7 all over again. Okay. So remember, what you're looking for is the y coordinate. And in order to find the y coordinate, you have to plug it in back into the original equation. That is the equation of the curve. Okay. Just like if you have a certain equation of a straight line or a curve, doesn't matter, and you have one coordinate and you wish to find the other, what do? You plug in the value of the coordinate that you have to find the other corresponding coordinate. Okay, could be the y coordinate, or you could use the y coordinate to find the x coordinate. Okay, so that's what we're doing. We're using the x coordinate to find the y coordinate. So let's do that. So y is equals to 2 squared is 4, 4 times 2 is 8, minus 2 minus 1. So 8 minus 2 is 6, 6 minus 1 is 5, which is the correct answer. So the coordinates are 2, 5. Now, this point was not actually called P. I just called it P. Okay. And there you go. That's the question solved. Okay. Now, here's something interesting. This is question number 7, by the way. It says the curve y equals to 2x squared plus 7x minus 4 and the line y equals to 5 meet at the points P and Q. Find the gradient of the curve at the point P and at the point Q. Now remember, if you wish to find out the gradient through dy by dx, the only thing that you want is the x-coordinate, or in this case, you want the x-coordinates because there are multiple points, okay? You have point P and you have point Q. So let's say point P has coordinates x1, y1, okay? And let's say point Q has coordinates x2, y2. But the thing is, what exactly are P and Q? P and Q are basically the points at which this curve and this line, they're meeting. And from prior knowledge, we should know that if you want to find out the point of intersection, doesn't matter whether it's in between two curves, two lines, a line and a curve, the only way to do that is to solve the two equations simultaneously. And that's exactly what I'm going to do. So both of them are equal to y. So that means we can use substitution. Sorry, this is minus 4. And the other equation is y equals to 5. So I'm going to substitute the two. 5 equals to 2x squared plus 7x minus 4. Let's get all the terms on one side. 2x squared plus 7x minus 9 equals to 0. Now, to save some time, I am going to use the polynomial feature in the calculator. Okay, I have a video on it. Make sure to check it out so that you know exactly how to get the most of whatever calculator it is that you're using. So x equals to 1 is one value. Okay, you can call it x1. And x2 is another value, which is minus 9 over 2. Okay, that means now we know how to find the gradient. Or in other words, we have the ingredients to find the gradient. Okay, now in this particular question, normally when you're finding the point of intersection, we always give the value of y also. Okay, now here the question is not asking you to find the value of y, and it doesn't make sense for the question to do that because the value of y is going to be 5. We already know that basically you have a curve and a straight line, which is a horizontal line. Okay, so let's say this is the curve. So this is what the line looks like, basically. So irrespective of whatever the x coordinate may be, which in this case are basically 1 and minus 9 over 2. So let's say this is 1 and this is minus 9 over 2. Now, this is definitely not drawn to scale. So let's say this is 1 and this is minus 9 over 2. So you can see that there's no need to worry about the y coordinate because that's going to be 5, okay? What you do need to worry about is the gradient of the tangent at these 2 points, okay? So if I plug in 1 in dy by dx, which I'm about to, we will find out the gradient of the tangent at 1. And then if I plug in minus 9 over 2, which again I'm about to, I will find out the gradient of the tangent at x equals to minus 9 over 2. So let's find out dy by dx, which means differentiating the equation of the curve. So that's going to be 4x plus 7. So 4x plus 7 is dy by dx. So let's plug in 1. Let's write this down. X equals to 1. That means dy by dx is equals to 4 into 1 plus 7. So 4 plus 7 is what? Is 11. So dy by dx equals to 11. That means the gradient of this tangent is equal to 11. And then let's plug in x equals to minus 9 over 2. See what happens. So 4x plus 7, x equals to minus 9 over 2. So dy by dx is equals to 4 into minus 9 over 2 plus 7. So 2 1s are, 2 2s are. So minus 2 into minus 9 is minus 18. Minus 18 plus 7. Better use a calculator. Minus 18 plus 7 is equal to minus 11. So there you go. That means the gradients are 11 and minus 11 respectively. Let's see if there's anything the question is asking for. Nope, the question is not asking you to find anything. Okay, so this is dy by dx at P, and this is the dy by dx at Q. And that's it. The question has now been solved. And that's it for this video also. In the next video, I'm going to do some more complex word problems, so make sure to check that out. And I'll see you then. Until then, take care. Bye-bye.